All right, gang, STAT1150. The purpose of this video, I think in the last video I told you that z-scores would be the last content uh, that I would cover, but then I reviewed the assignment, and I realized there were a couple of problems in there under, I think, what I would categorize as just problem solving with means. And so I wanted to run through a few examples. I think we have 5 examples here. Um, I got a meeting in 15 minutes, so I got to make this one kind of brief. There are 5 questions here, so we should get to it. So when we talk about problem solving with means, let's talk about again, how do we calculate a mean? Well, the mean of a data set is just the sum of the scores divided by n. And you can see if I take that and multiply both sides by n, the left side becomes n times x. So the sample size times the mean is just equal to the sum of the scores. This is very, very, very helpful in proceeding with these problems that I have over to the left. All right, so a professor reports that her 9 a.m. stats class, 15 students, had a mean exam score of 70. We don't know what those 15 scores are, but we know that the sum of those scores must be equal to what? Well, sample size times the mean. I'll grab my calculator. I can do that in my head, but I'm always afraid that I'm going to do something goofy. So 1050. So this is the sum of the scores for the 9 a.m. class. Now the 1 p.m. class, it looks like they performed a little better, more students, 32 students instead of 15. And I will tell you, when I pump the brakes here a little bit, I see a lot of students will want to take the 82 and add it to the 70 and divide by 2. Well, you can do that if this class has 15 students and this class has 15 students, or this class has 32 and that one has 32. If the number of students are the same, then you can perform just a equal weight of the means. But when you have more students in one class, as is reported here, that 82 takes on more weight. So we have to calculate the sum of the 1 p.m. class, which would be 32 students times a mean of 82. Now, I can't do that one in my head. So 2624. Well, there should be no surprise if I add these two together. I get 3674, which represents what? Well, it represents the sum of the scores for everyone. So it also should make perfect sense to you if I take the sum of the scores for everyone and the total amount of students. What do I get? What do I get when I take the sum divided by n? Well, I get the mean for everyone. So 3674 divided by 47 gives me 78.17. All right, number 2. The professor has 5 students in a class. The mean for the first exam was 82. I know that the sum for all the students is what? 82 times 5, 410. The absent-minded professor forgot to record one of the exam scores. If the other exam scores were recorded, what is the missing score? So all I have to do here is just take 410 and subtract away the 78, and subtract away the 65, and subtract away the 88, and subtract away the 89. So that's what I did on my calculator. I took the total sum of the scores that I knew had to be for the 5 students, and I subtracted the 4 scores that I have. So the 90 would be the missing score that would make my sum 410, which would have to be the case. So the missing score, student actually performed quite nicely at a 90. All right, number 3, a professor tells his students on the final day that the final exam will be canceled if the average on the midterm is 80 or higher. On the day of the exam, only 31 of the this actually happened to me one time, by the way, a class that I was teaching. And it puts a lot of pressure on in this case, the 32nd student. So the average for 31 students was 79. So we know, therefore, that the sum of the scores for the 31 students, again, working with the sums, is 2449. What they needed was for the 32 students to have an average of, shoot, why is this thing not, all right, sorry about that. So what they needed, if all 32 students, the average is going to be 80, then they need 2,560. Well, if I can take the sum that I needed, subtract the sum that I've got, so 2,560 minus 2,449, the student would need a score of 111. So if it was a 100-point test, it would be impossible for this 32nd student to raise the course average from 79 to 80. Now, question number 4, this is one that kind of blows my mind from time to time. I run into so many students who do not understand how to calculate a GPA. Well, I'm going to teach it to you, because a GPA is just a weighted average. Now, if all the scores, I'm sorry, if all the grades are like, well, so let's say that a student is taking like 5 3-credit courses, so the number of credits for each course is the same, then it's easy. Just add up the quality points and divide by however many courses you've taken. But a lot of times you'll see, as represented in the problem that I'm getting ready to do for you, um, sometimes we have 2-credit course, and sometimes we have 5-credit course, and so let's do it. Let's calculate the GPA for the student. So it looks like they have taken 2, 5, 9, 14. So they've taken 17 credit hours. So for the first course, the 2-credit, since an A is worth 4 points, they're going to get 8 credits, 8 quality points, I should say. For the B, they have a quality point of 3 times 3 credits. So they get 9 quality points. For the A, they're going to get 4 points times the 4 credits. For the 5-credit course, they're going to get 2 quality points times 5. And for the 3-credit course there, they get an A, they will get 4 credits times the number of credits, or I should say 4 quality points times the number of credits, equal to 12. So add that up, what do we get? 20, 30, 39, 55. Now, if I'll take 55 and divide it by the total number of credits, and I think we said that was equal to 17. Is that right? Let me make sure. So 5, 9, 14, 17, right. So 55 divided by 17, this student had a 3.24 GPA. Now, even a more complex problem, I think, is, imagine you're sitting there and you already have like 89 credits that you've already earned, and you're taking 17. Let's say, for example, that you have 90 credits that you've taken so far, and your current GPA is 3.18. What will be your GPA after completing this term? Well, clearly you can't take the 3.24 and the 3.18, add them together and divide by 2, because you have 90 credits that have contributed to this and only 17 credits that have contributed to this. And it turns out to be a weighted mean problem again. Just look at the sum. 90 times 3.18 plus 3.24 times 17. Add them up, you get total quality points, divide by 107. And my meeting's coming up, so I need to get this done pretty quickly. All right, number 5, presented as a histogram of exam scores for students from a large statistics class. What is the average? Well, why did I say average? It's what is the median, all right? So what we know is let's see, we have one student who earned 0, one student who earned a 1, it looks like 5 students who earned a 2. I would say this comes over to what, 8? So 8 students that have a 3. 15 students that have exam score of 4, and 25 students. So we have 1, 2, 7, 15, 30. We have 55 students. If I arrange these scores from the low all the way up to the high, I know that the median is going to be about at the 27th or 28th place, right? 55, I always come right to the center. Well, if I have 55 of these, then I know 27, 28, somewhere in there, is where my median is going to be located. Well, where does the 27th, 28th appear? Well, there's the first one, the second one. This is the first 7. This is the first 15. The next 15 will bring me up to 30. So my 27, 28 has to occur in this exam score right here. So my median must be equal to 4. Now, if that kind of stuff doesn't grab you, let's go to StatCrunch. You can see that I have the exam scores 0, 1, 2, 3, 4, 5 there. And you can see that I have the frequencies 1, 1, 5, 8, 15, 25, as I have taken from the histogram. Well, to find the mean and the median of this, we only need the median, but to find the mean, if you needed it, is really easy. Just go to summary stat, but instead of go to column, come down to grouped bin data. So my bins are in my exam score, and my counts are in the frequency. So grab what you need. I don't know, let's just grab some other stuff. It's simple once we get it set up. All right, compute. Just as we computed, the median is 4. If we needed the mean, it would also be 4, and the standard deviation is 1.20. All right, gang, that's all I got. Got a meeting. Take care.